Case study analysis of paint and coating failures. Mechanical damage. Lecture by Dr.G.Subramanian, Chief Scientist Retired, CSIR Central Electrochemical Research Institute. The approach adopted for the case study would provide the principal characteristics of the failure, main identifying features, basic problem solving techniques, and applied aspects of the failures. 3 painted galvanized roofing samples were subjected to failure analysis. All 3 of the galvanized roofing samples were from the same roofing panel, removed from the roof of a building in a city in the east central part of United States. A visual examination of the 3 roofing samples was undertaken. Sample 1, you can see the red spotted regions, 3 regions where you can see white rust and red corrosion products, white corrosion products and red rust. Sample 2, you can see the red arrowed one pointing out towards the dots, white rust, white corrosion product. Sample 3, white corrosion product is not visible. So the figure shows the photographs of the 3 roofing samples. 2 of the 3 samples had obvious localized corrosion in the coatings. The localized corrosion areas on the lesser localized corroded sample were believed to be representative of and similar to the start of localized corrosion on the most severely corroded sample. Low power microscopy using a stereo microscope revealed that the one sample that did not clearly appear to have localized corrosion also contained very small areas of localized corrosion. The localized corrosion initiated from the perforations in the coatings caused by mechanical damage, most likely while in service or during installation. Examples of the mechanical damage may be found in Figure 1. Figure 1 gives you stereo micrographs of mechanical damage. So, on the left side you can see mechanical damage at the magnification of 15x. You can see 3 red arrows pointing towards 3 corroded spots. You can see white corrosion products and red rust. Whereas on the right side figure shows the image shows you mechanical damage at an amplification of 22 times. You can see 3 red arrows pointing towards 3 corrosion spots. You can see white corrosion product and red rust. The perforations in the coating expose the galvanized panel to the atmosphere. As the exposed panel corrodes under the coating, a blister is formed in the coating. The atmosphere attacks the galvanized substrate via the perforation in the coating surface. The zinc sacrificially corrodes first as designed, creating a layer of white corrosion product on the substrate. Figure 2 represents the stereo micrographs of ringed corrosion pits. Sample 1, large corrosion pit at 6 magnification. You can see along the circumference, you can see white corrosion product. At the middle, you can see red rust. Sample 1, close-up of large corrosion pit at the magnification of 23 times. You can see white corrosion products at the peripheral ends and reddish orange corrosion products of the base substrate steel. However, as the white corrosion product builds up, the localized galvanic reaction will decrease and the steel substrate begins to corrode, leaving the ringed corrosion products, reddish orange corrosion products of steel, as shown in Figure 2 below. Figure 3 depicts typical coating cross section at 100 times magnification. Cross-sectional optical microscopy was used to determine whether the coating properties contributed to the corrosion of the roofing samples. The coatings were found to be relatively uniform with no porosity or delamination occurring within the coating layers. A micrograph of the typical cross section is given in Figure 3. You can see from the bottom side you can see mounting compound, paint, primer, next one is galvanized coating, another is steel substrate. So there is no imperfections in the coating. Further, grain boundary precipitates were observed within the galvanized layer. Paint, primer and galvanized layer thickness measurements using a filler unit eyepiece and an optical light microscope at 1000 magnification to determine whether inhomogeneous coating practices were a contributing factor to the extent of corrosion of the galvanized roofing panels. Since the samples were all from same roofing panel, the thickness measurements were similar, suggesting that the coating thickness may not be a major factor in the corrosion of the roofing panels. Figure 4 depicts the EDS spectrum of outermost rim of the corrosion pit showing high sulfur levels. Orange and white corrosion products from the outside of the localized corrosion area were taken and analyzed. The white crust was found to be zinc oxide and the orange crust obtained contained iron, zinc and oxygen. Sulfur was found on the outermost rim of the each analyzed corrosion area, as seen in the EDS spectrum shown below in figure 4. You can see the peaks of oxygen, zinc, silicon, aluminum, magnesium, sulfur, iron, chromium, titanium, potassium, etc. 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 Fourier transform infrared spectroscopy FTIR was used to determine the chemistry of the paint and the primer coatings. The paint was found to be a polyvinylidene fluoride. The primer was a polyester. Principal hardness tests were performed on the roofing samples as per ASTM D3363 to determine whether fluctuations in the roofing panels coating hardness were present. The measurements for all the samples were in the same range. Further, cross-hatch adhesion testing of the coatings was performed as per ASTM D3359. All the samples were classified as 5B, meaning that the edges of the cuts were completely smooth and none of the squares in the lattice were detached. No unforeseen areas of underlying corrosion were found. Summary. Localized corrosion was found on all three galvanized roofing samples. There were no irregularities in the coating layers. The observed small localized corrosion areas formed due to mechanical damage to the coating, exposing the steel substrate to the corrosion from the atmosphere. Due to the loss of overlying paint film for larger corroded areas, no direct evidence of mechanical damage was observed at these locations. However, due to the absence of any evidence to the contrary, it appears that similar circumstances, that is mechanical damage, occurred at these locations also, which resulted in corrosion of the substrate under the paint film. Thank you very much for watching and listening this video.